the chase and the hunt, and I set the pace when I'm running. I always
Namaste friends. So today is chapter 79 in the entire Python, and in the NumPy this is chapter 38. In the previous lecture we saw about simple arithmetic. So we saw how to actually do it, and we saw a few functions on the same. So in today's continuation, it is still the NumPy, and I think the NumPy will go for at least for 10 or 15 days, I believe. So today what we're going to be seeing in this thing is something called as LCM. So what is an L, what is a C, what is a M? During our 5th grade and stuff, we would have actually seen something called as a least common multiple, greatest common division, GCD, least common multiple. So the LCM is called the lowest common multiple. So what is the lowest common multiple? The lowest common multiple is the smallest number that is a common multiple of two numbers. I still don't understand this. What are you telling this? Well, let me explain with a code. So by now, we should be knowing all these things. Okay. By now, we should be knowing import NumPy SMP. We can take number 1 as 4, number 2 as this thing, and then we can actually multiply. And this LCM is the least common multiple. So 4 times 6, and we say print x. So let's actually see what it gives. It gives me 12. 4 times 6. And why is it 12? Because it's 24, right? So if you see 4 times 3 is 12. 6 times 2 is also 12. Okay. The lowest common multiple for both these things, for both the numbers, it is basically 12. So that is why it is like this. Now say suppose I have 4, 6. I do by 2. It goes as 2, 3. Okay. So I know I have 3 and I know I have 4. So I know if I put 4 here and I put 6 here, I divide by 2, 2, 3. So this is not divisible. So this 2 and 3 is there. Okay. That is exactly coming here. 4 times 3 is 12. 6 times 2 is also 12. So that is why the lowest common multiple is 12. Did you understand? Did I make sense? And that is the syntax. Number 1, number 2, and LCM is the lowest common multiple, which is nothing but a product. And then we are printing x. Now the same thing we can actually do in order to find it in the arrays. Okay. So if you want to find it in the arrays, we can use a reduce method. Reduce open and close parenthesis. Okay. So in this case, we can reduce the array by one dimension. By reduce is basically reducing, right? You're decreasing. So in this case, we're actually reducing the array. Okay. So let's actually take here and let's actually do this. I import a NumPy, I import an array, and then I have an array, single dimensional array, 3, 6, and 9. I tend to find the lowest common multiple. I say reduce my array, and then I say print my x. Now the answer I'm going to get is 18. And why is it 18? So if I do a 3, 3, 1, 2, 3, and then I have 2 and 3. Okay, so that will become 3. If I say 3, 6, 9, if I divide by 3, 3, 1, 2, 3. So this is 2 and 3 and then 3. So that will be 6 times 3 is 18. So that is what it is. See here, that is exactly what I told you. That is exactly what I told you. If I have 3, 6, and 9, and then if I divide it by 3, 1, 2, 3, and this is not further divisible. So this 2 times 3 is 6, and 6 times 3 is 18, and that is what it is actually giving me. So that is what I'm actually reducing it by one array, and that is what, this is there. Now, if I want to find an example, find the lowest common multiple of all values in an array where it contains an integer from 1 to 10. Okay, so if I want to actually find this, I take this, I go here, I do this. I import NumPy. I have this array, which is the range of 1, 11, which is from 1 to 10. And then I reduce this. When I reduce this and I say print x, let's see. I have 2520, and you have to do it in a similar manner. And this is the lowest common multiple. So this is where the computer becomes so fast and so effective. Here I actually was dividing, I was showing you, but for this I can't because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But this is a lowest common multiple. All right. All right, friends. So that is the lecture for today, lowest common multiple. So tomorrow we'll be seeing GCD. I trust you to have actually seen this lecture, probably understood the same, and maybe liked it. If you have any questions, kindly contact me. I'll actually try to explain to the best of my abilities. Like always, I would like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree for allowing me to follow my passion. Till we see next time, thank you, take care, and cheers.